Hey there, hello everyone. Welcome to Cyber Bytes. Today, in this episode, we will be looking and learning on the foundations on how we can configure our SSH server in a secure way and harden its implementation. Now, before we begin, I would request you that if you like my videos and work, then please do comment, like, share, and subscribe the channel and videos. This will certainly help the channel grow and encourage me to create more of such useful and educational content. Now, getting back to our topic, SSH, or widely referred to as the secure shell, is a protocol for secure remote login from one computer to other. It also provides us with various alternatives for strong authentication and protects communication security and integrity with strong encryption. It is the best alternative for remote login and system management compared to FTP and Telnet, which are insecure as the data is passed through the channel in plain text. During my security engagements at the client location, I have found that various assets inside the client's network widely use SSH for remote management. However, these assets, that is the servers, the routers, the switches, the firewalls, etc., whatever the assets the client might have, do have inefficient deployment. I have seen somewhat inefficient deployments, or I feel that the deployment could have been better in a secure from the security point of view. So for that, especially on servers, I may say that for servers, you have a lot of configuration options available. If I talk about them, you can have better security. So with that note, I have some of the options that can be used that are built into SSH servers configuration file that we can use and make our SSH servers deployment more secure and more strong. So today in this video, we will discuss some very basic ways in which we can make minor changes into the SSH server configuration file and enhance the security of our server in a very positive way. So here in front of our screen, we can see is an Ubuntu 20.04 server, and this server is the default installation out of the box. And what we will be doing is we will be trying to harden the SSH service on this server, and we will be trying to implement some of the security features and enhance the security of this SSH service. So currently we will be initiating our work by installing the what we'll do is we'll just enable the firewall first. So currently, as you can see, that status currently for the UFW, that is the uncomplicated firewall, it is inactive. So what we'll do, we will just set up the basic rules for incoming and outgoing traffic, and then we will set up to allow only SSH connections for our reference purposes, and we will just move on with the further steps in this way. Okay, so first what we will do is we will just enable the firewall, that is the sudo UFW enable, UFW enable. So we'll enable our firewall by giving our password. So we have enabled our firewall and it is enabled on startup. Now we will just put two default rules. So one default rule is to allow outgoing traffic. So we will just start with that, sudo UFW default allow, that is our rule for outgoing. So we are telling UFW to, as a default rule for allowing the traffic, for outgoing traffic, we'll just set it to allow. So now what we'll do is we will be denying the incoming traffic as a default rule. So in case if we miss some rules, if we just mess up somewhere, so default rule set will be to just deny any incoming traffic. So sudo UFW deny incoming. Sorry, just messed up. So I made a typo. Default deny incoming. So okay, so this is our current firewall rule set. Now after setting up the default allowing and denying traffic, we will just make sure that our Ubuntu server is accessible via other computers with the by opening the port on our firewall. So we'll do is sudo UFW allow SSH. So we will allow SSH traffic. So the rule has been added. So now with this rule added, what we can do is we can actually using our SSH client, that is putty or other clients, we can manage our server here. So I will just bring up the screens where we will be having our SSH clients ready, and we will be using it that. For also the IP address of our box is here is to be configured to harden. It is 192.168.1.5, and we will be using another Kali instance here also via terminal, and we will be using that Kali instance to connect with this instance and proceed with the further hardening steps. So here we are connecting with the IP address that our Ubuntu server is running, that is 192.168.1.5, and we will connect with that. So we are getting this, so we'll accept and we will log in here. Okay, so we have entered. Now what we will do is we will just arrange our screens here, and here on the other side of the screen we can see the Kali Linux machine that we are having. So on one side we have Kali Linux machine, and on the other side we will be having our CyberBytes server, which we will be using it for hardening purposes. So now let us proceed with step by step. All right, so what we will do currently now, the time being we will not be using the Kali, because we will be first focusing on the firewall rule setting of our CyberBytes server. So I will just minimize this thing and I will just maximize. Okay, so here what we will do first is we will just see the status. So here currently rule set is to allow TCP traffic coming to port 22. So coming from anywhere, here the action is currently allowed. Now have a look here, that current action is to allow the traffic. Now what we'll do is first, that in case someone is trying to, you can say, trying to brute force, or in case someone is trying multiple connections to this server at a time, so we will just rate limit that connection. So first and foremost thing we will be doing is that we will be first rate limiting the connection to our server. So we will be making sure that no one tries to do some brute forcing or password attacks on our server. So we'll just limit it from there. So for that we will be using the command sudo ufw limit, and we will be using the option that ssh tcp. So we're limiting the connections, and we will just put a comment that rate limiting rule. Okay, so rule is updated now. Now have a look at the status now. Earlier it was the action was set to allow, now the action is set to limit, and we have added our comment, and that comment has gone through. So here actually you can see that before we are putting a rate limiting, we were having action of allow, and after we are putting the rate limiting option, now the action is set to limit. Now this will try to stop your brute forcing attacks, but still we can deploy more options, or you can say deploy more security layers to stop this also. So we will be using fail to ban also. I'll be showing you briefly how we can use fail to ban. So after rate limiting our traffic on our firewall, now we are adding another layer of security for our server. So we will be using a package called fail to ban. Now fail to ban previously was a separate package. Now it is available in official Ubuntu repository. So the installation and configuration of fail to ban is very straightforward. So to install fail to ban, we will be issuing the command sudo apt-get install fail to ban, and we will be giving our password, and we are good to go. So it will take a bit of time. I will pause the video. All right, so our fail to ban tool has been installed on our server. So it took a couple of minutes. I will also request you to kindly go through the documentation. I will be providing you the documentation in the link for fail to ban. For extensive, you can say, customization as per your requirement, you can do that. But here we will be doing a quick configuration and, you can say, test fire for fail to ban to see the things are in order. So first and foremost, what we will do is after installing fail to ban we will be using some of the configuration files locally, and we will work on those local files for the protection of our server. So first and foremost, we will be just doing one thing. We'll just go to our folder of fail to ban that is located in etc fail to ban, and here are the files. Now there are various files. So one of the important file is the fail-to-ban.conf and jail.conf. Now the fail to ban tool by default will give preference to the files which are local. So what we will do, we'll copy the jail.conf file as jail.local. So we will do sudo cp jail.conf jail.local, and we will be having our file which is jail.local. Now we will make changes in the file of jail.local. So some for specific to SSH service only we will be making the changes, but fail to ban has if you look at the jail.conf file, you will be having an idea of that you can virtually set up any service protection for any service that you want. So we will be just proceeding with the local file, and we will be just opening this file in our nano text editor with elevated privileges, sudo nano and jail.local. There we go. So this is the default, and these are the parameters and options that you have. So we will be making the changes in those parameters. So in the default one, we will be having the option of ignore IP. So one option is about ignoring the IP. So jailed this fail to ban tool will be ignoring the IP address traffic that is coming from an IP address that is a local IP address or any other IP address from where you are managing your server. So we will be just using ignore IP, and we'll be using that is 127.0.0.1 and IPv6 for our local machine. Next is the ban time. So the ban time is the number of seconds that the host is banned. So default is 10 minutes. You can change it, but for our demo sake, it is okay. You can change it to 1 day also if you like, depending on how much time you want to ban some host that is trying to brute force. Next is the find time. That is the host is banned if it is generated max retry during the last find time. So that is like you can say a checkpoint from where the host has been, you can say, doing a maximum retries of you can say some requests. So find time is also 10 minutes. If you want, you can put it whatever you like. Next is the max retry, which is the number of failures before a host will be getting banned. So that is, you can say, after 5 tries the host will be getting banned. So this is how we are setting up the thing. So also we should know that if you refer to documentation, I have also seen some part, but not all, I must say, that it is also having a feature that if you want, you can also use sendmail that is in your Linux machine, that it will also help you to give you a report of what is happening. It will send the emails, but we don't want that right now. Now after that, we will be just going into the sshd module here. So we will just go. So in green, if you can see here, so there are various modules. See here, sshd server, what is the, you can say, port that you want to you can say give a monitoring on. So basically port SSH, that is the port 22, log path backend, all are actually right. This is by default, this is enabled. So we will just go with these parameters and try to test this fail to ban for us. Write it out and we'll just exit. And now what we will do is we'll just restart the service, systemctl restart fail to ban.service. We have restarted, and now let us have a look. So let us try to do one thing. We will deliberately try to brute force the username already that we know and password from our common password list that we have from our Kali Linux machine and view what is happening. Okay, so for brute forcing, we will be using the tool Hydra, our X Hydra, and we will see what we are getting. So this is our tool, and our target IP here is 192.168. We are setting the protocol port to 22. Protocol is, as we know, that it is SSH, and we'll be using show attempts, be verbose, passwords, username. We know the username, that is cyberbytes. We'll just generate passwords like 5 characters, password. So we are just randomly putting, we just want to generate some password and show the things. We will be just setting it to like somewhat more, and we will just try to start here and see how the things we are getting. So it is trying. Now you can see that it is unable to connect and it is getting protocol error. So our fail to ban has successfully worked here. It is still trying. It is saying that connection is refused. So now if you want to see that which IP has been banned, you can see here. Now after performing our brute force attack, and we already know that our IP should be banned, we were able to see in the window of our Hydra. So like so here we can see that yeah, it was actually connection was refused, and timeout was coming. To view what has happened, we can go to the folder here, that it is the logs for fail to ban events are stored in the default log location, that is the var log, and here is the fail to ban.log file. So we'll just tail it. Here you can see that, see, this is trying to brute force 2, 3, 4, 5, 6, 7, and like this. It is giving ban 192.168.1.6. So our server is banned. So let us see if it has really banned us or not. So let us just close our Hydra and let us see it for ourselves. So we will just do SSH, and we will be doing it 5. So it is telling that connection is refused. So our ban is successful. So our IP has been banned because it has tried to brute force, and failed to ban has flagged this IP as brute forcing IP. So this has worked. So what we have done here is that we have tried to put a very basic firewall rule set. So if fail to ban, I don't think it will miss, but if it is there, then we have a redundant control in place. So here we need to first you can say remove this, unban this IP. So we'll just go to unban the IP address that we want. We need to give sudo fail to ban client, and we'll be just telling our fail to ban client to set sshd. So for sshd daemon, we need to unban IP. It is 192.168.1.6. We need to unban that IP. All right, so it is one. So command is successful. Now let us confirm the same here from our terminal of Kali Linux. So okay, so we are able to log in now as our IP has been unbanned. So this is how actually you can at a basic level use fail to ban to protect your SSH service. So now let us begin with the part where we will be setting up key-based authentication. So earlier the example what we saw was basically password-based authentication, and in many ways it is, you can say, prone to brute force attack, but still we have managed to put some of the checks and balances in place to actually slow down the brute force attack. But still, if we want a better security than password based authentication, we can opt for key based authentication. So most of the time what we see during our pen test is that, as I told you earlier at the beginning of the video, that the client's internal assets have mostly I have seen that they are putting password based authentication. It still could be made better by adding key based authentication and other you can say others two-factor authentication. That is also possible. I'll be showing you how we can do it, but first let us begin with the key based authentication. So we have two terminals here side by side. One is our Kali Linux which is logged into our CyberBytes, and one is a CyberBytes terminal here. So what we'll do is I will just exit from here and I will just go to our Kali Linux terminal. So what I will do is, on our Kali Linux machine, I will generate my public private key pair. So one key will be, that is the private key that will be staying on my Kali Linux machine, and the other public key that I will be transferring it to the SSH server, that is the Ubuntu CyberBytes Ubuntu server, and from then only we will be setting up the key based authentication. So from server 1 to server 2 we'll be doing. So first what we have to do is prepare our server and generate the keys. So first we'll be using the command ssh-keygen. By default, ssh-keygen, whenever we are hitting the command, it will generate a 2048-bit RSA key pair. Now this is secure enough. Now if we want to have a more strong key pair, you can just put P and you can just put 4096 if you want. So if you want you can say a more secure one, so you can go with the 4096. That is also possible, but we will just stick to 2048, the default ones. So for demonstration purpose it is there. So it is generating, and this will be the default location, that is the home kali.ssh, that is the hidden folder ID RSA. This is the default location where your keys will be saved and stored. Each and every time your server is trying to connect to the remote server by public private key pair, this will be a default folder where it will be looking up for the key pair. So we will just put, so if you want, you can just secure your key by encrypting it on your server by entering a passphrase if you want. So I'm not putting, if you want you can put that also, and our key is generated. What we'll do, we'll just navigate to our .ssh and we will see ID RSA. So it is having one file, that is ID RSA pub, so that is a public key, and the other file, that is the known host. So whatever host this Kali Linux machine has connected with, it is having a record for that. Okay, you should mind that if you are if you already have an SSH key based authentication, and if you are generating this key pair again, so the other previous key that are stored in the .ssh folder, they might get overwritten and your previous logins might get invalidated. So please bear that in mind. So if you want to use the same keys for you can say entering you can say logging into your SSH instance, other instances, so you can skip this step altogether, and we can actually go with the copy ID. So now one part is complete where we have created public private key pair of our server from which we are trying to manage other server. So now we will push our public key to the CyberBytes server. So we'll be using the command ssh copy ID, and we'll be using CyberBytes. So where we want to put CyberBytes at the rate 192.8.1.5, that is the IP address of our server, and the username this. So this public key of our Kali Linux machine will be copied to our CyberBytes server, which is located at the IP address 192.168.1.5. And yes, we are hitting our password. All right, so one key has been added. Most of our work, that is 50% complete. So now if we want, we can log in, but this time, see, if you want to log in there, let me show you. So it has logged in. So already our key is there. That is why. Now what we have to do, we have to make some changes in our, you can say, a server sshd file. So of our CyberBytes server, to make sure that next time whenever we are trying to log into our CyberBytes server, the system is forced to use the key-based authentication only. Still, we know that password-based authentication is functioning, so we need to just disable that module. So a couple of changes that we have to make. So we will just go ahead and make those changes. So I will just use this CyberBytes server right now. So I will just maximize this window, and yeah. So we will just moving to the file that is on ssh, and fine. Now we have our sshd config file. So this is our sshd config, this file. So we will be working with this file, and we will just opening nano. All right, all the configuration that we will be doing this configuration here. So let us go step by step. Here in this file, we will just go and make some changes. So here we can see this directive, public key authentication, this pub key authentication, that has been commented out. So we will uncomment this. So we will be enabling the public key authentication. We will need to be making some more changes. So yeah, password authentication has been set to yes. So we will just and we will be setting it to no. So we don't want password authentication. We also do not want empty passwords. You can say a redundant control that we can put. This should work. Let us check. Everything is fine, and we will just say Control O. We will restarting the SSH service. Sorry, typo. Okay. So we will exit from here, and now what we'll do, we'll try to re-log in. Now you can see I do not have to type the password. I can directly log into this SSH server, my CyberBytes server, with the public key that I want. So this is how I can actually proceed with the password, you can say key-based authentication. So which is much better than password authentication. So the catch here comes that if you are missing, or if you can say if your keys are public keys, private keys and public key pair are actually getting misplaced, or your private key of your server is getting misplaced, so it might create an issue. So I highly recommend that you follow proper practices of key management, and you should have them in place. So keep a backup of those keys at a safe location, and you can actually keep on logging to a server for as long as you want. So this was about that. Certainly public key authentication is much more better than password authentication. So that will limit the, you can say, reduce the attack surface. So once now, if any other one is trying to, even if they are using your username, and if you're trying to hit, you can say, your server for SSH, so they will be rejected because it is using public key authentication. Same will be going if you're trying to do a brute force, it will still not allow automatically. It will tell that it is not using password authentication. So this is how you can secure your server in one way. Now let us move ahead with the other part, where actually we'll make some more changes and make our SSH server a bit more secure. Now let us do one thing. Let us now put a warning banner. Now you might have seen that some of the organizations do put out warning banner when the user is logging into a terminal or on a system. So we can do some sort of thing like that. So SSH server is also having that facility. So we'll be doing that thing. So we have to just make a very small change for that. Let us first create a banner file. So small banner or small notice file that we can create. So we can just go to that folder etc. And here we can actually create a banner file. So we can say touch notice like so we can give, and we will be giving our password, and we will be just using nano. So we will be opening this file. So let us put something like notice super secure server, you should be an server. So any notice if you want, you can put. It is just for demonstration purpose. So we are saving this file. All right, so now let us go to our SSH folder, and we will make some changes in the file. So here what we will do is put the file name as our banner. We are putting banner, and here we'll be just adding the path of the banner, which is at etc notice, restart, exit, and let us come back again and see if we are getting banner. Yeah, we got the banner here. So in this way you can put your proprietary banner if you want, or it will look cool. Okay, fine. So this is how actually you can put a banner. So that's an informational thing, but still it certainly looks good and it add a touch of customization. All right, now let us move on the demonstration on how actually we can add two-factor authentication for our SSH logins. Now, we all actually know that two-factor authentication is the most commonly used and one of the most preferred method for securing our logins or authentication. So here we will be using the Google Authenticator. So already the library for that has been provided by Google on their GitHub page. Here, let me just pull it. So this is our Google Authenticator libpam module. So we will be just installing this libpam module and following the instructions and the options that have been specified. And I will be showing you step by step how actually we can achieve two-factor authentication for our SSH server. First, we will just install the libpam Google Authenticator, and already I assume that you are already using Google Authenticator application on your Android or iOS device. So if you have that ready, you can actually just scan the QR code that will be generating in a few minutes, and you're good to go. Now, if you do not have, you can actually download the Google Authenticator app. I will be giving you the links in the description section. Here we will be first installing the Google Authenticator, libpam Google Authenticator module. So we have to issue the command sudo apt-get install libpam Google Authenticator. Typographic mistake. Now it is okay. So yes, the needed packages will be downloaded and installed for us. And after installation, we will be just running this Google Authenticator tool and we'll be generating a QR code. So yes, it has been installed. So there are two options you can use. You can either use Google Authenticator and you can go with the process flow if you want, or alternately you can go with the options that are there in the documentation. For one stop, you can just hit the command and go likewise. So both of those options are good, no problem. So I'll be using the command to save time. So let us just write the command Google Authenticator. We'll be using the -d minus t and r, that is 3, minus capital R is 30. I'll be briefly explaining you what these command options are. So let us go to the documentation page. Now talking about the options that we are seeing here. So in the documentation, if you refer the values here, that is the -d, that is actually referring to disallow the reuse of tokens. So that is a security feature that we do not want our tokens to be reused. So that is the D, that is this one, -d, that is disallow reuse, disallow multiple uses of the same authentication token. So we do not want that. Next is small f, sorry. So that is basically related to forcing. So write secret key settings without first confirming with user. Next is -t, small t, that is we are telling that it should be time based. So here that is small t, that is time based, set up time based verification, which is what we want. Now after that we are telling that the small r, that is rate limiting. So we are setting this value to 3. Now what it is, that it will be clear to it when we understand -R here. So -R is specifying that the value that we have specified 30 here. After every 30 seconds, we will be getting a new code, and we have to set the rate limiting that after every 30 seconds, 3 times if the code is not, you can say, correct. So we have to rate limit that. So for that, basically every 30 seconds, and we are setting it to 3. Next is the -w, that is minimal window, which is we are disabling windows of concurrently valid codes. So you can refer the documentation. This is just an overview for your reference. So for the ease of usage that we are using. So this is the way in which we can actually set up your Google Authenticator at a very basic level. So we'll just hit enter and we are getting a QR code. So QR code, and along with the QR code, we are getting a secret key. We are getting the verification code. So if you are not having QR code reader, or if you are unable to read that, you can just put this verification key. These are your emergency scratch codes or emergency codes for backup. So if you lose it somewhere, so you can just write it down or print it down somewhere. So what I will do, I will just scan these codes and I will generate a token for that. So I will take my phone and I will just scan the QR code. There I have it. I have my CyberBytes server entered in my phone and I am ready to go. So this is how actually we can just enable. So the half part is done. Now let us configure our server to actually accept this authentication module. So after generating the QR code and adding this QR code to our Google Authenticator app, now we will make sure that this thing works along with our SSH server. So for that, we will first make changes in our PAM module, that is the password authentication module of our SSH service. So for that, we will be just navigating to our the file, that is, let me just clear it, /etc/pam.d, and we will be just going it. Okay, first let us go to this folder. Yeah, and we'll be seeing ssh.d. There is one file. Yeah, sshd, sorry, not d. So we'll be just use sudo nano. So here we need to make some changes. We have to add this line here. Let me just go down below and add this line to keep a track of what we are doing. So we will be just doing auth required pam_google_authenticator. So this is the name of the process, that is our system object, and we'll be just adding nulloc here. So nulloc basically is a situation we will be adding this because there might be some users that have still not configured their two-factor authentication. So once we make sure that all of our users who are logging into our SSH server are configured to use two-factor authentication using the QR codes, then we can remove this nulloc file. So this will be like permanent thing that, okay, fine, now everything is set. Now for the meantime, we'll put this like this only. We will make some more changes, and here there is one line that is include common auth. Yeah, here is the line. So include common auth, we will just comment out this line. So we do not want common auth right now. Now let us save this file. So I will just do one thing, and I will just add one more thing added by CyberBytes. So this will keep a track of the changes. Fine. So one thing is done. Now we will be heading out to our, and we'll be just using sshd config. And here we need to make some more changes, a couple of changes only, not much. So first of all, what we will do is we will be just enabling our challenge response authentication. That is what we are doing. So we will just head over to the line which is saying that challenge response authentication. Currently challenge response authentication, that has been set to no. We will be setting it to yes. So one thing is there. Next, after that, and we will be telling password authentication module to put the authentications. So here I will just use PAM, yes, because we need to have a keyboard interactive, because we need to input our codes. Now what we'll do is we will tell the PAM to actually add authentication modules that public key is used and then keyboard interactive. So keyboard interaction will be there. So for adding our Google codes that we are adding. So here I will just add again, added by CyberBytes. Next we will say authentication methods and public key. One is our public key that we are using, and then comma, and then keyboard interactive. So this is what we can do. Next up, we will just save this file, Control O. Next, we will restart the service, and what we'll do, we'll just try to exit from here, and now we will see if the things are in their line or not. What we have seen, I will just hit the SSH at CyberBytes at 192.168.1.5. I got my banner, and now it is, after verifying my public key, it is actually now asking me for my verification code. So what I will do is I will head over to my Google Authenticator app, and I will just enter the code. So that is the code. There we go. We have actually logged into our server using Google's two-factor authentication. This method specific for securing your authentication into your SSH server is highly recommended. I have seen users getting, you can say, administrators using username, password, maintaining a separate password sheet, and all sorts of stuff. So passwords can become sometimes risky, and they are much more obsolete now. With availability of these good methods for authentication, I highly recommend that you should be using these methods for entering, you can say, authenticating to your servers based on your SSH two-factor authentication. So this was about that. Now next up, what we can do is we can make some more changes in our SSH server. So some minor changes. Let us go to that cd sshd config. Now we will make some small changes. One change is, like, if you want to kick out users after they are inactive for a certain amount of time, you can set that. So here it is client alive interval. So I have set it to 100 seconds. More than 100 seconds the client is, you can say, not responding, so automatically his session will be terminated. One thing that you can do next, after that, you have to set this client alive count max to 0. So these two things go hand in hand, so you have to do that. Next up, what you can do is you can actually allow certain users or group into your SSH server. That is also there. So I will recommend using whitelist, not blacklist. So here you can say you need to allow only some users. So you can just add a directive allow users, say for example Kali here. So this is the user that is coming to your, you can say, server. You can actually add more users if you want. So you can add multiple users, ABC, whatever the users are, you can add. You can also use allow groups if you want. If you want for allowing users, allow user 1, user 2, or allow groups also if you want, allow group root or allow group whatever you are there. Just make these changes and you are actually good to go, and your server is pretty much secured from unauthorized access. So this was in my mind about hardening tips for SSH server. There are other tips also, but these are the most, you can say, basic configuration settings that you can go for. So the most common problem for SSH remains of about unauthorized access. So someone is trying to brute force your SSH server and trying to gain access and hijacking the server instance. So you can prevent it using the two-factor authentication plus public key authentication. So this is the best alternative you can get. But on the flip side, you need to manage your keys also. Please do comment and let me know how you like the video. In case also, I would request you again, please do hit a like, please do comment, please do subscribe the channel if you like my work. Please do go give your inputs on what you want in your next upcoming videos. So what I'm planning is, after security tools demonstration, I am trying to put a video on hardening and security, and then I am putting it alternatively. So I'm currently working on 2-3 demonstrations more. As I get time, I will be adding more and more videos. So this was all, and I will be seeing you in the next video. So take care and goodbye.